Hi everybody, this lesson focuses on filtering mechanism of graph query, which mainly discusses how to read and compose a filter in a query command. We've seen filters a lot in previous lessons. They appear in the query parameters or templates that denote node and edge. Filter is an expression wrapped by a curly brace to judge whether the current metadata meets some specific filtering conditions. It's usually composed of operators and operands. Most of the operators and their precedence follows the mainstream programming languages. Let's try out without my manager. The expression in this node filter invokes an operand that calls the schema name of current metadata. This expression reads as the schema of current node equals card. When there's no alias defined for a find nodes command, the system automatically defines an alias nodes for it. The symbol at denotes schema, and the word this is a system alias which denotes the current metadata. In most cases where no semantic ambiguity occurs, the alias this is always omitted. The symbol at is also a unary conditional operator known as schema checker to judge whether the schema of current metadata equals a specified value by attaching the value right behind, like this. These three expressions are equivalent. This expression calls the property value of current metadata. It reads as the property level of current node is in a closed interval from 2 to 4. The system alias this also can be omitted, and this filter is simplified as you may notice, this filter finds nodes of two different schemas since we didn't filter the schema of nodes. To call both the schema and property of current metadata, simply combine both their expressions with logical operator AND, like this. Or like this. Or more recommended, like this. Besides the current metadata, a filter expression in the path template may also call the metadata to the left of current metadata in the path. This is the interstep filtering scenario introduced in the previous lesson. Let's review. This statement finds a transaction path of 5 steps where the time of each edge is greater than that of the previous edge, namely ascending along the path direction. Another example of referring to previous metadata in the path can be illustrated with paths that are head to tail. In this statement, the initial node is given an alias, which is called by the terminal node. Not only the metadata in the path, any data, from constant to alias, can be called to filter the current metadata. This statement contains a with clause that names an array with 2 strings as IDs. Then a find nodes command uses this array as a source that the node ID must come from. The alias being called this time, which is N1, is bank card C8001 found by the first command. It is then called by the second command, which uses the value of balance of card 001 to filter its current node. The alias N1 in this example and the IDs in the previous example, they both are data columns that have only one row. Queries that call external alias with multiple rows have some details to look at. We will study that in the lesson of data stream. The calculation of an expression may involve value conversion among number, string, time, and Boolean, according to the specification of operators. For example, this filter returns nodes whose balance is between 5,000 and 10,000. If we omit part of the expression like this, then the balance will be converted to Boolean to represent the judgment by the filter. Any non-zero balance will be judged as true, and that node will be returned. When invoking schema and property in the UQL, if their names contain characters other than letters, numbers, and underscore, then backquotes should be wrapped around their names. This is a graph model with a node schema named VIP-course, and it has a property named classroom hash. To find nodes with classroom number R003, we should set filter like this. Otherwise, the UQL is not considered as legal. Here is the summary of Ultipa's filtering mechanism. Most of them are covered in the demonstration just now. Most of operators employed by UQL's filtering mechanism are the same as mainstream programming languages, except for the filtering of schema. Let's review its usage.